Welcome back, guys. This is 1-5, solving absolute value inequalities. So in the last video, we solved absolute value equations, and here are the steps that we used to do that. I have this on the screen because it's going to guide us into solving absolute value inequalities, which is a little bit different. But I just want to recap on solving absolute value equations. So if we were given something like the absolute value of x is equal to b, what would we do? What we would do would be take this and split it into two separate equations. You're supposed to set up two equations, one with an equal to the positive b and one equal to the negative b. So here we have x equals positive b and x equals negative b, and that was your answer. It's not quite so simple for inequalities. Here are the two different examples of what you could have for inequalities. In these cases, it's the same exact thing we just did in the last slide, but we could have a greater than sign or we could have a less than sign. I really want you to think about these as grade or, okay, remember or compound inequalities. We're going to bring that back and use it today. And less than and compound equalities, we're also going to bring that back and use it today. So if you don't remember those, you can probably go back and refresh just a little bit, get out your notes, just because we're going to be doing a lot of that today after we get the breakdown. Just like absolute value equations, inequalities are going to do almost the same thing. So remember how I was talking about the compound inequalities? When we split this into two, we're going to split it into two inequalities separated by the words or, making it an or compound inequality. And over here, because we have less than, we're going to split this into two that are separated by the word and. Okay, so this is going to be an and compound inequality. What we're going to do for the greater than is, because we have greater than, we're going to carry that greater than symbol down. And now I have x is greater than my positive b. On the other side of my or, I'm going to have x, and this is what gets tricky. I do have the negative b on the other side, but I also flip the sign. So when we are doing equals, we would have an equals here and an equals here. But in this case, we carry down our original, so our original greater than with the positive b, and we carry down the opposite. So we flip our sign for less than and negative b. Notice that the flipping and the negative numbers are together again. Those rules always seem to combine together. When we have negatives and flipping, they're always compact. Okay, over on the less than side, okay, same thing happens over here. We're going to carry down this less than, and we have x is less than our original b here. On the other side, we're going to do the same thing. So we are going to carry down our x. We're flipping the sign here and making it greater than to go with our negative b. So again, we flip the sign with the negative. I wrote up some rules to get you through solving absolute value inequalities. They look very similar to the solving absolute value equations. It's still a 3-step process, but you know the steps are a little different. So step 1 is still the same. We still want to isolate the absolute value. So we either want to have the absolute value bars and greater than, or we want to have the absolute value bars and less than. All by itself, we don't want any numbers on the outside of our absolute value, okay? Step 2 is we will rewrite the compound inequality as these steps that I just showed you in the last slide. And step 3 is that we'll graph. So let's get into it. I have the absolute value of 3x plus 6 is greater than or equal to 12. So the absolute value is actually already isolated. There's nothing on the outside of these absolute value bars. And I can just go ahead and rewrite this as a compound inequality. So, because I have greater than, I'm going to split this into two inequalities separated by the word or. My first one, I'm going to carry down the same exact sign. I'm going to carry down my greater than or equal to, and I'm going to leave that with the positive 12. On the other side, I'm going to flip my inequality sign so I have less than or equal to, and I'm going to put that with my negative of the 12. And now I have a compound inequality, which you know how to solve because we just did that last week. First step here is to divide or subtract 6 on both sides. We're going to go ahead and do that. On this side, we get 3x is greater than or equal to 12. On this side, we get 3x is less than or equal to negative 18. Divide by 3 on both sides. The answer is x is on this side is x is the answer on this side is x is greater than or equal to 4, and the answer on this side is x is less than or equal to 6. Don't forget that you have to bring down that or and keep these two inequalities separated by this word or. Kind of brings them all together, makes it a compound inequality. Now we need to graph. Now remember, when you're graphing with or, it doesn't really matter where they overlap, you just need to graph them both on the same line. So if we graph the x is greater than or equal to 4, we know we need a closed circle on 4 and that we are shading to the right. X is less than or equal to -6, we're going to put a closed circle on the -6 and we are going to shade to the left. And we're all done with that one. Let's do an example of when it's less than. So same problem, but this time we're using a less than. So we already know our absolute value is by this itself, and we could get rid of, or we don't have to do step 1, we can just go right to step 2. So we're going to break this down into two inequalities separated by the word and. Okay, the first side, we're going to use our original inequality sign, which is less than or equal to. So we have less than or equal to our regular number 12. On the other side, we're going to flip our sign and put it with the negative. So we're going to put greater than or equal to, which is the opposite, and we're going to put that with the -12. And now I have a compound inequality that I already know how to solve. So we're going to go ahead and solve this together. So same concept as the last one, we're going to subtract 6 from all sides. That's going to give me 3x is less than or equal to 12 on this side, and 3x is greater than or equal to -18 on that side. Next step will be to divide by 3. We will divide by 3 on all sides. That's going to give me x is less than or equal to 4 over here, and x is greater than or equal to -6 over here. Don't forget that you need to bring down that and to compound these two inequalities together. And now we have this compound inequality that we know how to graph. Here's our graph. We want to make sure that we have 4 and -6 on our graph. So remember, when we're graphing and compound inequalities, you're graphing where they overlap. So I'm going to do like a working graph, and then I'm going to clean my graph up at the end. So x is less than or equal to 4, closed circle on 4, shading to the left. X is greater than or equal to -6. I'm going to put a closed circle on -6 and shade to the right. And now I just want to focus on my overlapping area. So it overlaps between -6 and 4. So I'm just going to clean this up so it's just shaded in between there. And I'm all done. Let's work on one that's a little bit harder. I want to do one that we have to do step 1. So in this one, we don't have the absolute value by itself. So we have to get rid of this 3 and we have to get rid of this -9 before we can move on to step 2. So just like we practiced when we were doing the absolute value equations, first we're going to get rid of that -9 by adding 9 to both sides. That's going to give us 3. Absolute value of 2x plus 6 is less than 24. It's still not by itself because I have that 3 on the outside. So I'm going to actually divide by 3 because multiplication is happening between those two. So divide by 3 on both sides, and that's going to give me the absolute value of 2x plus 6 is less than 8. Now my absolute value is isolated. It's on one side all by itself, and I can go ahead and move to step 2. Okay, well, rewrite as a compound inequality. I can go two ways here. Is this a greater than or a less than sign? I need to look at my sign. I have less than. So don't forget that a good way to remember that is saying less than. I want an and. So if you forget, you can always refer back to step 2 and look at these little pieces here. So I have a less than. I definitely want to have and in the middle. I'm going to start with less than on one side. So splitting into 2, and is in the middle. On the left side, we're using our less than symbol with the original 8 that they provided for me, okay? And on the right side, we are going to use the flipped sign with a -8. So we want to make the number negative, and we want to flip our sign to greater than. And now we know how to solve this. So we're going to go ahead and do this. Subtract 6 from both sides. When we do that, we get 2x is less than 2 on this side, and 2x is greater than negative 14 on that side. Divide by 2 on both sides, and we should get x is less than 1 over here, and x is greater than negative 7 here. Don't forget this is a compound inequality. You do need to bring down that and. Don't forget it. It makes it a compound inequality and not just two inequalities. Okay? And now we can go ahead and graph. We have 1 and negative 7 on this graph here. We're going to start with 1. So the x is less than 1. We want an open circle on 1, and we want to shade to the right. To the left. X is greater than negative 7. We want an open circle on negative 7, and we want to be shading to the right. Okay, this is an and, so we only shade where they're overlapping because we want our stipulations to be that x is less than 1 and also x is greater than 7. So where is it both? It is both between negative 7 and 1. So we go ahead and we clean this up, and we're all done here. All right, guys, go give the worksheet a try, and I'll see you next time.